In this problem, we're taking a look at marriages and divorces. So this is for years between 2003 and 2008. Now keep in mind, here we're not plotting anything regarding years. We're just looking at what happens to marriages and what happens to divorces. So we're trying to study the relationship between the two. In this case, we want marriages and divorces to be able to look at how one increases or decreases as the other increases. So as marriages increase, do divorces also increase? What is the relationship? So we plot it, and we see pretty quickly that, number one, the linear relationship is not the best one because they jump all about. But one could almost argue that ignoring a couple of points, the trend is somewhat upward because from where they started to where they ended, it's a bit of an increase, but maybe this is a little too scattered for us to be able to predict it. But nonetheless, it gives us a relationship to study. So here's our equation. Let's call it D and M for divorces and marriages. And in millions, it doesn't really matter since they're both in millions. It's equivalent to saying 2.245 marriages for every 0.927 divorces, or 2,245 marriages and 927 corresponding divorces. So in this case, we're going to let divorces be our output, and our initial value is 0.17 about, and our rate of change is 0.3, so plus 0.3 m in this case. So this is how we determine divorces. Okay, so does it appear to fit? Well, not really. The R squared is pretty low. It's only about 21%, so not that great, but nonetheless, again, we're going to run with it. The rate of change is 0.3. Now, if you want to put it over 1, again, that's a pretty good idea. Now, this is change in output over change in input. So this is divorces per marriages. Okay, so that means there are 0.3 divorces for every 1 marriage. Well, that doesn't really make sense. Well, alternatively, that's the same thing as 3 divorces for every 10 marriages. So as marriages increase by 10, the number of divorces increases by 3. How many divorces could we expect to see if there were 2.5 million marriages? Well, that means that we were looking for the number of divorces. We know that there are 2.5 million marriages, and we have 0.17 plus 0.3 times 2.5, giving us 0.17 plus 0.3 times 2.5, and that comes out to 0.92. So we would expect 0.92 million marriages in that case. Well, what if there were 1.5 million divorces? How many marriages would there be in that case? So what we want to know, I'm going to write kind of over here, is if we have 1.15 divorces, we replace D with that value, 0.17 plus 0.3 times M, how many marriages would there be? So we do our typical subtract the constant. That gives us 1.33 equals 0.3 M. 1.33 divided by 0.3 comes out to 4.4 equals M. So there are approximately 4.4 million marriages when there are 1.33 million divorces. 1.5 million divorces. And here's an interesting aspect. If there were 0 divorces, if there were 0 marriages, we would expect that there would still be 0.17 divorces. In other words, there would be 0.17 million divorces if there were 0 million marriages. So it looks like that's not a good thing, that if there aren't enough marriages, then the divorces take place quite a bit faster.